To really understand chemistry, I suppose we have to understand the particle that makes up everything, and that's the atom. Up to now, you've probably seen the model shown with protons and neutrons in the nucleus and electrons orbiting around like our moon orbits the Earth, or if you like, we orbit the sun. We tend to make these things with circular patterns, and I think it's more about making it easier to understand or easier to conceptualise and think about in our minds rather than reality. Now, we have huge problems with atoms because atoms are so tiny. The human mind gets there and goes blank when we think about really, really big things or really, really small things, because we can't get it into our daily lives about what actually goes on. So remember, it's a theory about what's going on, and it's based upon a whole series of experiments that people have done and come up with a best guess approach, if you like, to what really goes on inside the atom. So if we start from way back, and when I say way back I mean really, really long time ago, several thousand years ago, they came up with the name atomos for indivisible particles that they thought made up everything. And I think you can guess from there where the name atoms came from. But the whole thing was they thought they were little indivisible particles, and this sort of theory lasted for a long, long time before we even contemplated changing it. It wasn't really until the work of Dalton that we looked at any other sort of theory, and he put together a nice little theory. He kept the indivisible part, which we now of course we know is not correct, but that's another story. But his claim to fame was he said that when atoms, or if you like elements, combine, they do so in fixed whole number ratios, like carbon dioxide is always CO2, water is always H2O. So we have 2 atoms of hydrogen to 1 atom of oxygen. Very good, and it explains, I suppose, the basis of formula, and that leads us to conservation of mass and equations. For so long we didn't really understand charged particles and charged ideas, and it wasn't until Thomson came along with his famous experiment where he actually used a cathode ray tube to actually to see that things had positive and negative parts. And he is probably most famously remembered for naming the electron, discovering and naming the electron. And that opened up a whole new ballgame, because this meant that the atom actually did have subparts. So because we knew it was neutral, all chemicals are neutral, then suddenly we had to realise there had to be a balance between the two, positives and negatives. So Thomson's idea was the fact that it was like a muffin or a plum pudding, where you've got certain things, bits of fruit in a muffin embedded in the pastry, and the bits of fruit were the positive charge and the pastry was negative charge. Or you can think of it the other way around, it doesn't really matter, because as long as you realise there was this balance of positive and negative charges going on. Shortly afterwards, we seemed to find a fellow who delved in the idea of radiation, and it was very, very new and exciting discovery that had just occurred. Mr. Rutherford did his famous experiment, more to come on that later, but it's another thing we need to know for exams. It is rather specified in the SL guide the IB hands out. So he suddenly discovered that instead of being this mix of it like our muffin idea, we have a positive centre and negative around it. But most interestingly, he found that the atom was mostly empty space. So that opened up a whole series of ideas. He originally thought that the electrons must move around this positive centre in orbits, because planetary systems were easy to view, and we had some ideas about them. We started then to think more about what was going on with these electrons. There, of course, were other people delving into the nucleus, and a fellow by the name of Chadwick found these neutrally charged particles which have become known as neutrons that came from the nucleus of the atom. But that's all we need to know about that. But the electrons are a whole new story. And we thought they must be moving around, and as we went through it and we discovered more about the electron, and we know that some people think they're particles and other people think they're waves, so it became very, very difficult to match all these theories together. But the one thing we sort of do think about now is the fact that electrons are random in their path, and we are basically predicting where we think we could find them. So when we talk about this in terms of electrons, we're saying we think we'll find the electrons here. Our search for the truth about atoms is based upon our technology. And as our technology changes, we get more and more and more information, which we then use to form a better theory. Now, for anyone who's paid any attention to what's going on in the world of science, you'll know that the discovery of the confirmation of the discovery of the Higgs boson, the particle that gives an atom its mass, a couple of years ago in CERN, that's the European Atomic Commission, and they spent a lot of time smashing particles together in a big particle accelerator to actually find that this particle does exist. And so now we've been able to tighten our idea of the atoms even more. And now, before you ask it, I'll just go with it. People say, what do I need to know for the test? Well, essentially, we test you on the Bohr model of the atom. Now, Bohr came after Rutherford and Chadwick, and he identified with the fact that he liked their points with the fact you have a small nucleus, he liked the fact that it was empty space, and he liked the fact the electrons were outside the nucleus moving around. But his orbitals were based upon the energy of the electrons, and he basically said that electrons will occupy areas around the nucleus, called orbitals, which are of certain energy, and they would fill them up from the inside, from the lowest energy, and gradually occupy them, maintaining this filling from the lowest energy available point of view. So that's the one we occupy at the moment, and there'll be another little program on electrons a bit later.